Welcome to the gap analysis section. This is Jean-Baptiste Bouquet. In this part, we are going to identify the different gaps we encounter in this project and the requirements created to solve these gaps. Let's first consider the general gaps. The first gap is due to the globalization of the work. Indeed, we are working with geographically distributed collaborators which are in different time zones. In order to be efficient, we need to use new communication tools to communicate globally, and so be able to work together by sharing information on the planning, the decision, and so on. The second general gap concerns the environmental impact during the design process. We need to take care of the carbon footprint and consider the recyclability of the product. We also need to maximize the energy conservation. The third general gap is linked to the constant evolution of the technology, which need to be included into the product. To do so, the keyword is flexibility, so the product can be adapted to any changes very quickly. The final general gap is about the use of the modern technique and methods to design quickly robust open engineering systems. In order to do so, we need to use tools such as computer-aided engineering, rapid prototyping, and virtual simulation. We can now consider a task clarification gap. Indeed, the open engineering systems are a perfect solution to the mice customization. However, in order to be successful, the product has to fulfill the requirements list wanted by the customers. That is why we need to use tools such as voice of the customer and the reverse engineering to assure the customer's satisfaction. At last, we can consider three embodiment gaps. The first one takes into consideration the regulation such as industrial, federal, and state one, but also the social criteria. By considering the manufacturing globalization, we also need to take care of the global regularization. The solution is to use tools in order to evaluate the process design against the technical, economic, and social criteria and adapt the criteria to the next design cycle. The second embodiment gap is about the exponential development of the technical tools such as CAE or virtual simulation. Design teams have now the opportunity to obtain quick and robust designs. So, the new tools and methods can support the design of products by applying simulation, modeling, and verification of results. The last gap is related to the needs of testing and validating the design. To be more efficient, this test should better be elaborating during the design process. In order to do so, we need to provide tools to support the design testing and then use this method to verify and validate the design.
Hello, my name is Brian Salgi, and I will be going through the first part of the business case portion of this video. Basically, I'll be going through the business plan and our initial business research, and then I will be handing it off to Jason, who will be going through some of our market research, and he will show you some field interviews that we conducted with some potential future customers of our product. Marketplace and competition. First took a look at the market. Portable devices and portable electronics have become increasingly popular over the last few years, and this trend is likely to continue for several years to come. People are on the move, and sometimes they are not able to charge their devices, being that they're not close to electrical outlets or what have you. So having this product might be beneficial to them. And there's no other product in the market currently like this, but we have noticed that other products, other out-of-the-ordinary shoes have been successful. Shoes that have wheels, shoes that light up, shoes that act as calorie counters. So the potential for this product to be successful is, we feel, great. Target customer, when we were trying to define who the target customer is going to be, we split it up into three main categories. First one being workplace. So these would be people who are at work on their feet a lot. They could be in a construction site. They could be working in a hospital. Next category is athletes. people jogging, hiking, running, people playing different sports. And the last and final category is youth in general. Children or teenagers always on the move, always up to date with electrical and portable devices. Customer needs. We will be going further into customer needs in the requirements section of the video, but to give a overall quick, broad rundown of customer needs, I'll go through it now. Basically, this shoe needs to resemble an ordinary shoe. It needs to be comfortable, durable, waterproof, safe, needs to be affordable. For this particular shoe, the electronic devices should not hinder in its performance, shouldn't get in the way. And of course, the shoe should be application appropriate. So if it's meant for a jogger, it should be a sneaker, it should be comfortable, etc. Mass customization. We realize as a group that the demand for products to be able to be customized is great, and we want to factor that into our products. Different aspects of it that we would like to be able to be customized are the size, the style, the color, the sole, the treads. So we would like to factor that into our product and our design. Safety issues. Since we are taking what is a normal shoe and adding electrical devices to the sole of the shoe, we want to make sure that this product that we are bringing to market is safe, it's stable, it retains proper ergonomics, and again, since it is electronics, we want to make sure that it's waterproof enough to keep moisture away from those electronics. Distribution strategy. We have a few different options we can go here. At the least, we would like to partner with an established firm for the manufacturing side. Perhaps a company that is already producing shoes, sneakers, or a firm that has made shoes in the past. Potentially, we could even partner with a major shoe brand, become a separate division within that company, or we can sell our product to them directly. Supply chain. Our vendors of our parts are going to depend mainly on our final bill of materials. We're going to try to stick with off-the-shelf parts as opposed to custom parts to save with cost and the overall final price of the product. And again, partnering with established or major shoe brands will ease supply chain issues and possibly bring down cost by partnering with a big company. Service and warranty. We took a look at if we want to offer a warranty with our shoes. We had asked ourselves first, will providing servicing of the shoe be cost effective? And the answer is probably not. It was probably going to be cheaper just to replace a shoe if it becomes faulty or damaged in the field. So keeping that in mind, for the design of the shoe, we have to make sure that it is durable enough to work to a 1 to 2 year warranty. Return on investment. When we market our shoe, we can advertise how it's going to save money on batteries or save money on your electric bill by not having to recharge your electronic devices as much. But really we want to market that this is a green shoe. This is a growing trend recently, going green, helping the environment. So we want to really market that this is going to be a green shoe. With that said, I would like to hand it off to Jason, who will continue the business case portion of the market research.
Thank you, Brian. We're here today at the Wilton Mall in Saratoga Springs, New York to do some market research. We want to talk to a few people, see what interests them in a shoe and what they look for, and kind of demonstrate what we went through with our market research. So I have my first volunteer here. Come on over. Hi. Nice to meet you. about comfort.
Comfort,
Now,
yeah.
if you don't mind, what do you do for a living?
I'm a graduate student
Okay, so you're probably on your feet quite a bit.
at a hospital, yeah. I internship at a
Okay.
hospital.
Oh, at a hospital. Sure. You're
All
probably
day.
walking really good. Now, how did you feel with all that time you spent on your feet walking around? You were able to use that productively to charge a battery and run an iPod or your cell phone.
That would be neat.
Basically, what we're doing this marketing for is for a new, it's a shoe with an electro-hydraulic mechanism that will allow you to do this, that. Do you think you'd be interested in that?
Maybe, yeah.
Okay, now if you were to purchase such a shoe, how much would you be willing to pay for a shoe with this mechanism?
Maybe $20 or $30 over the cost of a comparable shoe.
Okay, great. Well, thank you for your time. I'll let you get back to shop. What do you look for in a sneaker?
In a sneaker, I definitely want something versatile that I could use inside, outside, working out, lifting weights, light walks, playing with kids.
Okay.
Something very supportive,
Supportive.
kind of heavy duty, comfortable at the same time.
Great. Now, would you ever be interested in a shoe with an electro-hydraulic mechanism that, as you're walking, would be able to power a small device like an iPod or a camera?
Wow. Would definitely be interested in finding out about that. I wouldn't want to feel something like that when I'm walking, as far as
Okay.
like pressure or any pain or anything.
It would go in the sole. So
Yeah.
That's good to know.
So, but
Great.
I would definitely be interested in finding out about something like that.
Now, how much would you be willing to pay for such a shoe?
I guess I would, if it's a good quality from a good company, I think I maybe probably expect it to be one side or the other of $100.
Great. Well, thank you very much.
Okay.
So what do you look for in a walking shoe or a sneaker?
I need something that's got a solid sole, that's very supportive, especially with good arch support from the platform.
Ah, okay. Now, what helps you differentiate one shoe from another?
I just look for the quality of the shoe, how durable it is, and what kind of support it's going to give me.
Okay. Quality and durability.
Yeah.
Important. Very nice. Now, would you be interested if there was a shoe with an electro-hydraulic mechanism in it that, as you walked, would be able to power a small device like a phone or a camera?
You going to electrocute me?
No, it would be very safe, but that's a very good point.
You going to make me run faster? Jump higher?
No, it won't.
I suppose, as long as it's safe, I'd be interested in it.
Okay, great. Well, thank you very much. So we just left the mall after talking with a half dozen potential customers, and we got some really good market research. Everyone seemed to feel they wanted the same things in a shoe. They wanted it to be versatile, very comfortable, and have it be overall good quality and durable. And also talking with everyone, they all seemed interested in the possibility of having a shoe that could generate power as they walked, as long as it was safe and reliable. And furthermore, talking to them, they seemed open to the idea that it would be worth paying a premium on top of the normal cost of a shoe for that device. So that's all the time we have for today. Thank you.
Welcome to the customer input section. This is Mark Overmeyer, and later you will hear from Chad Hume. Our discussion of requirements will be broken into 3 sections. The first section, customer requirements, will give our definition of a customer requirement, tell how we use the group to develop our customer requirements, and then we'll give 3 examples. The second section, product requirements, will give our definition of a product requirement, talk about the conversion from customer requirements to product requirements, and then give 3 examples. The third section will detail the handoff of our requirements list to the design and analysis teams.